This video is about activation energy. So the keyword in the question is the rate constant K and temperature T and were to be plotted on a graph would produce a linear line. And the concept of this question is understanding the Arrhenius equation. So this is the Arrhenius equation, which can be found in section 1 of the data booklet. And the equation gives us the terms K, which is the rate constant, equals to A, which is our frequency factor, times e to the power of negative EA, which is our activation energy, over R, which is our gas constant, and finally times T, which is temperature. And this Arrhenius equation comes in another form, which can also be found in the same section of the data booklet. In this form, it gives us ln K equals to negative EA over RT plus ln A. And in this format, it's easier to comprehend the Arrhenius equation because it's very similar to a linear equation, which is y equal mx plus b. You might not see how this is very similar, so I'm going to rewrite the Arrhenius equation one more time. So now we can see how ln K is our y variable, our slope is negative EA over R, our x variable is 1 over T, and then our b variable is ln A. And so now that we have this Arrhenius equation in this format, we can plot it on a graph. So on our graph, on the x-axis, we would have 1 over T. On our y-axis, we would have ln K. The graph looks like so. And at our y-intercept would be ln A. And our slope would be negative EA over R. So looking at this graph, it makes sense because as we change temperature, it changes our rate of reaction. So you can see a definite relationship there. But there's also a starting point of the frequency factor, because frequency factors gives us the number of how frequently the molecules will collide at the correct orientation in order for a successful chemical reaction. And then our slope is determined by the activation energy, how much energy it takes to for a reaction to occur. So if we were to go back to the question, our final answer would be D, because remember, on our y-axis is ln K, and on our x-axis is 1 over T to have a linear graph.